So rake face, this is the rake face of the tool. The rake face is inclined basically at a rake angle. Function of the rake face is to direct the chip and or guide the chip to follow the path for the removal. Okay, or when the chip is removed from the workpiece, the rake face directs the chip to be disposed of. Okay. And another one was flank face. So the flank face is the face of the tool that is slightly above from the surface of the newly machined newly machined workpiece. Okay, it is towards the shiny face of the workpiece that has been made, that has been machined now. Further, it is inclined at an angle that is known as relief angle or rake angle. In short, with the rake face, the angle is known as rake angle. It is represented by alpha, whereas with the flank face, the angle is known as relief angle or clearance angle, and the relief of flank face has a function to prevent the newly machined surface of the workpiece from being scratching. Okay.
Yes.
Would you please let me know that in between these two figures, is there the relief or clearest angle are have same angles or they are different? If they are same, what is the effect? Or if they are different, what is how they affected the workpiece? So in the figure A,
Submit
a
तरफ
definite
हुआ है
relief or clearest angle has been given that prevents the newly machined surface from being scratching. Whereas in the figure B, there is no clearance or angle or relief angle with the flank face is given, so we can observe or we can see the effects of the marks or effect of the scratches that are represented by these black lines on the newly machined surface. So now from the figure you have it is clear to you people what is flank face, what is rake face, okay, and what are the rake angle and clearance angle. So flank wear, it mostly occurs on the relief face of the tool and at the side relief angle. Crater wear, it mostly occurs on the rake face of the tool. Why the crater wear occurs? Crater wear occurs because the newly formed chip have a high temperature when they when the chip is separated from the workpiece, and due to the high temperature they stick with the rake face of the tool, and due to this sticking of the tool they often take smaller pieces or smaller particles of the rake face along with them upon the removal. So due to this sticking and due to this taking of the particles of the rake face along with the chips, wear occurs at the rake face of the tool. That wear is known as crater wear. So it means that we can minimize the crater wear. How we can minimize the crater wear? The crater wear can be minimized with the help of the chipping or by using the chipping. So what is the chipping process? Chipping process is the removal or breaking away of small pieces of the sorry. I'm going to repeat again. So how crater wear can be minimized? The crater wear can be minimized by using the chip breakers. So what is the chip breaker? So what is a chip breaker? The chip breaker is used to prevent the rake face of the tool. So chip breaker decreases the radius of the curvature of the chip and eventually breaks it. Means how if you do not use a chip breaker, that you can see the length of the curved chips become too much large. So as the length of these curved chips become too much large, they get stuck with the rake face. So we install or we attach a chip breaker with the rake face of the tool. This chip breaker, function of this chip breaker is to break the chip and to break the chip or continuous chips into discontinuous chips. Okay. This is the tool. With the tool, we attach a chip breaker and we clamp the chip breaker with the tool with the help of a clamp, so that it can be rigid and it can be affected with by the force of the chips. So there are a few types Okay. Sometimes the rake face is also rake face is also designed in such a way to attach a chip breaker and to direct the newly formed chips. So these are the three figures in which the grooves are made in order to remove the chip. So this is the sharp cutting edge that removes the chip from the workpiece, and this is the line that you people are seeing, observing. This line directs or breaks the chip. So this line also, by design, it works as a chip breaker. So groove in the cutting tool act as a chip breaker. Most cutting tool are now use or insert with a built-in chip breaker feature. So chip breaker, it breaks the long continuous chip as these are undesirable, so it breaks long continuous chips. Chip breaker is a piece of metal that is clamped to the rake face of the tool, which bends the chips and break the chips. The chips can also be broken by changing the tool geometry, thereby controlling the chip flow. So these are the this is the tool geometry which can help us in order to break the chips and thus prevent the break face of the tool. This is another example. There's a chips in the turning operation, tightly curled chip. This is a formation of the curled chip. Chip hits the workpiece and the break. So this is the what I have told you in the previous slide. This you can say this groove. How this groove is. What is the function of this groove? When the chip strikes with this groove, it automatically breaks and thrown away. Continuous chip readily move away from the workpiece. This is the continuous chip, and the chip hits the tool shank and it break offs. Okay, got it? Okay, the last concept, the chipping. What is the chipping process? The chipping is a breaking away of small pieces from the cutting edge of the tool means. So this is the chipping and we have to prevent it. So now due to this chip formation, the wear and tear of the tool occurs. Refer to the figure A. This is the flank face, and the flank face, the wear occur at the flank face is known as flank wear, and this is the rake face. At the rake face, the wear occur is known as crater wear. So flank wear and cutting wear in the cutting tool, the tool moves to the left as in figure 21.3. Okay, I'm going to again view of the rake face of the turning tool. View of the rake face of the turning tool showing various wear patterns. So in the figure B, you can easily see that the rake, this is a rake face, and with the rake face, this is the removal of the rake face material due to the formation of the chips, and this material has been taken away by the chips with themselves. So the wear occur at this point is known as crater wear. Okay, and this is the flank face that is slightly inclined above from the machined surface. Okay, this is the chipped cutting edge, so you can see at the rake face. Okay, so view of the flank face of the turning tool. And number D, this figure, type of wear on a turning tool. Number one is flank wear. The number one is called flank wear. So in the face, you can see on the flank face there is a flank wear. Number two, crater wear. So crater wear has been appeared on the rake face. This is the crater wear. Number three, chipped cutting edge. So this is the cutting edge that has been chipped away from during the cutting operation on the rake face. Thermal cracking on the rake surface as the tool become hot during the machining operation, the thermal cracks are appear on the surface of the tool. Number five, build up edges. So a few slightly build up edges have been formed on the surface of the tool. And sixth one is catastrophic failure, that the cutting edge of the tool has been broken away and it is no more of use. So the fifth failure. So you can see there is a dotted line dash that is one of these dashes. So it means that after one revolution, this much millimeter, the distance between this continuous line and this dashed line, the distance between these two lines, it will be machined after each revolution. So it is the feed. So the thickness or the distance by which the tool has been penetrated into the workpiece, it is known as the depth of cut, and speed, rotational speed of the job is known as cutting speed and is represented by V.
يعني उसमें वियर एंड टियर आ सकते हैं?
मटेरियल उसमें वियर एंड टियर तो नहीं आता, लेकिन उसके ऊपर जो मार्क्स होते हैं ना, जो मतलब निशानात पड़ते हैं इसके, वो आ जाते हैं। असल में जब इसको हम माइक्रोस्कोपिकली देखते हैं, जब हमारे पास अगर यूनिवर्सिटी ओपन हुई तो मैं आपको बताऊंगा कि एक मशीन सर्फेस को आप जब माइक्रोस्कोप में रख के देखोगे तो उसकी ऊपर हद से ज्यादा मार्क्स बने होते हैं, मतलब मशीन के मार्क्स होते हैं, वो हमें नजर आते हैं। सो ये जो कंटिन्यूस शिप्स हैं, ये उसकी जॉब की सर्विस को भी खराब करती हैं, ठीक है। सो कंटिन्यूस शिप्स आर मेड एट हाई cutting speed, low feed, low depth of cut, and at high rake angles. Okay. The formation of the continuous ships can be minimized by continuous ship can be broken with the help of the chip breakers, and they are undesirable in case of automated machine tools. Built-up edges, they are made when the decline material are manufactured at low or medium cutting speeds, and these edges are the pieces or the ending pieces of the chips that remain at the workpiece. They can be minimized or reduced by increasing the rake angle. Thus, the depth of cut is reduced, and we get rid of these built-up edges. Further, these build-up edges reduce the poor surface finish. Discontinuous chips are usually manufactured on the cost, and these are the segments of the small the chips are separated in the small segments and loosely attached to each other. Hard or brittle material, just like cast iron, they are manufactured, they are made in the machining of these materials. So brittle fracture take place along the shear plane before any tangible plastic flow. Means no such plastic deformation, plastic deformation occurs, just like in case of continuous chips, they become easily break off. Discontinuous chips form in the brittle material at low rake angles and large depth of cuts. Threaded chips are non-homogeneous chips. These are semi-continuous chips with zones low and high shear strain. Means you can in this microscopic level you can see a saw type, just like you can see this is saw teeth, a saw type figure of the serrated chips, and low thermal conductivity and strength metal of the material exhibit this kind of chips.